Hey guys, so welcome back. Yeah, we're working on this old Zenith AM FM radio. We started this last episode and we went through and got the thing to operate more or less. It had some noise issues. We had a tube or two issues that was wrong. And anyway, we got that all working, and now we're going through and addressing replacement of a number of components. One of the main problems I had with this was that the band selector switch was really noisy and was almost, I almost couldn't turn it. So I had to get this thing out, get it cleaned up, popped it in the ultrasonic cleaner, got it lubricated. It now turns pretty easily. It doesn't slip around real easy, but it definitely, I can do it without a knob. And but in order to get that out, I had to tear out a lot of things all at once. While I had it out, I had to replace a number of components, a number of capacitors, a number of resistors, and some of them were double or even more than that, their values, just from moisture gain. Anyway, so we're going to get back onto this and put this in, and we'll see if this thing still works. Hope so. Okay, so we got the switcher installed. Made up all 17 of the 18 connections that were here. So the number of capacitors, number of resistors in this whole area has been a lot of work. So it'll be interesting to see if this thing still works. So we'll turn it on together and we'll find out if it's still okay. Another thing I had to do is there's a lot of this black wiring. I was surprised to not have more of this. I know it's quite common in Zeniths. So this is an example of the rubber wiring that goes bad, right? And what I found was the black wire is bad in here, and there's also some brown wire down here at the bottom that is bad. I've had a part where it shattered off, and I got a piece of tape around it right now just because I want to run this voltage test. There's some red wire in here that you see right in here. It's actually okay. I can put my needle nose on it and it's squishy. But if you do that on this, you better have your eye protection on because it'll just shatter right at you. Okay, you hear it falling around the shop. All right, so we got a bunch of that removed and replaced in there. It's running along the bottom. It's pretty much heater wires. There's another long one right up here. You can see in the back. It comes down to here. All right, so I think enough delaying. I'm going to try to hook this thing up and put power to it for the first time. Just doing this wiring here was about 2 hours. I did lose one lug that came off, and so I had to make a patch for it here, and I used a piece of stranded cable here so it had some flexibility, and did a pigtail to go connect up to this hardwired single wire resistor, so that if this gets moved, then that has a lot of flexibility in it, so it's not straining that rather poor connection now, I guess. All right, so I'm ready to I've got to put the tubes back in it. I removed tubes for when I was doing soldering on those sockets. So we get those tubes back in, and then we'll go to power up. Be right back. Okay, so I got the band switch put in. It's installed now. Got all the lines hooked up. It took a couple hours to do all that, but I went and checked them all very carefully against the drawing we made, which was very helpful, actually. So I recommend it. And so I got that done. I've double checked everything. I've checked to see if I'm getting any shorts across them. I had a whole lot of connections open. I've changed a lot of capacitors. I've changed quite a few resistors that were in here. This is the first power up I've had after all of this disconnection and disruption in this area. So basically everything's been done up to about here and about to here. I've got a few more in here and to do to the middle, but I can get to those pretty easily. So this will be the first power up we've done since I've done that much work. I'm curious to see how this is going to turn out. I'm going to go ahead and record it just in case something interesting happens. But anyway, here we go. I got the bulb in the circuit. I do it this way just in case, keep them from slipping into each other. All right, so we've got that hooked up. I've got the bulb in the circuit, voltage all the way down, power coming up. Power switch is on. Turn the volume down a little bit. Okay, we've done a lot of work in here, so I'm going to be watching the current very closely. I don't know if you can see it pretty well here. And here's the voltage back here. So I'll call out the voltage. We're about 30 volts, about 100 milliamps, 40 volts, 50 volts, 60 volts, 70 volts, 80 volts, about 120 milliamps, 90 volts, 100 volts, still under 200 milliamps, 110 volts or 200 milliamps. It's about 117 right there. Here comes the conduction. I hear noise. We're just under 300 milliamps. Okay, I think I'm in AM, and I still haven't fixed the band on the dial cord yet. Okay, I'm getting reception.
Checks and balances only for one side, and they don't. I can't see.
Okay, so we're getting
30 yards and 6 yards of carry.
So we're getting good reaction on AM. A little bit of noise on this. I haven't cleaned that switch yet, I guess. And so let's go on and switch over to FM and see how we do. Okay, that's FM.
With News Wrap, a summary of some of the news in or affecting LGBTQ community.
Okay, well the camera cut off because my card was full, so I had to go in there and dump a bunch of files off the camera. Let me go back to where we were. Let's get the voltage back up here to 117. Tube's warm up here. So I was hearing a lot of static, almost like Silver Mica Disease kind of sound again. And so I was looking at what was going on. I moved some tubes around. Hear this? Okay. So I dug around in here and tried to find out what's going on with this before I realized the camera wasn't recording anymore. And if you remember, zoom in here a little bit. If you remember, once before I had a problem with touching a capacitor, and the capacitor just came loose. Those two of them just came off down here. Well, I had forgotten that one had come off here as well on the volume control. So if I make that connection back, let's see if I can do this. Here, that's killing that noise. This is part of the bias. This goes back and provides a bias feedback to the cathode on the audio tube. So what I've done is that I think this capacitor is probably not any good, so I rigged them up another one. This is a 0.047. So basically I'm just going to bypass this capacitor with this jumper using a new cap. Alright, now volume control acts a little more normal. So I'm still getting that warming up sound problem on that limiter tube, I believe. So I'm going to go through and continue to check resistors and so forth to see if that's not part of my problem is throwing tubes into different voltage areas. I'm going to continue on through and we'll just see what we end up with. I'm not going to give up yet on whether we've got Silver Mica or not. If I go to AM, and by the way, you notice how quiet the switch is now, switching between positions. So AM's working fine. And the switching to FM is quiet. But I'm still getting some noise and some elements of the FM circuit. And a few minutes later, the noise is completely gone. So I still think it's a tube issue. It's warming up. But I'm not having any of the problems that I was having earlier with that noise that we were talking about. So I'm going to move on forward with getting the rest of these resistors that need to be changed out in here. As you see all these flags in here, they need to be probably addressed. And then I got some of these caps that need to be replaced. So I'm going to get all that done and we'll see how this thing starts to perform then. And I may take this volume control off and do a little more work with it, but it seems to be generally okay. And then I need to look at going in and doing the rewiring of the power lines. I've got a CL90 here to put in. I think I may put it on this because it's an older unit. And I may go ahead and put a fuse in. Since I've got some convenient holes that are here, I can mount a fuse block on there. It doesn't have a transformer in it, but it's an older unit, and I just want to take care of it. It's a nice one. Okay, I continue to make my way through here, and I've been checking it as I go, and I've now got the volume control mostly out. I'm going to just use this opportunity to, because I had a couple of capacitors to attach to it, so I went ahead and took the opportunity to take this out so I could get better access to these ports for spraying inside of it. And so I'll get that put back in and we'll continue on. Okay, so I've been busy. I've sprayed cleaned the volume control and it's working real smoothly now. I've replaced a number of additional capacitors. I just have a few left to go. Replaced a lot of resistors that were bad. There was quite a few of them that were bad in here. And also did some work on the power cord. So I mentioned a while ago that there was also a brown one that ran along the bottom down here, and of course this one is also shot. So yeah, so we got that done, but I did it in mind of thinking about how I was going to wire up the power for this. So the way I'm going to have it is that the hot from polarized cord is going to come in and it's going to go to the on-off switch. So I rewired it to where that's where the hot lead will go, and then it comes down to here to a black line that's down underneath here. I'll zoom in just a little bit. And there was a filter capacitor that had been down here below that I took out, one of the brown drops in fact, and replaced it with a Y2 capacitor, which is right in here. You can maybe see it back in there. So the Y2 then comes from this post and goes to chassis ground. So the hot will come in, hit the switch, it'll go through the fuse and the CL90 first. It'll hit the switch after that, and then come here, it'll hit the Y2 here for filtering any RF on the line, and then that comes down here and goes to the rectifier tube and so forth from there. Okay, and then I'm going to do something different with this lead here, which was meant to go up to the FM antenna, so that this is, the idea of this was you put a cap on here on one of the lines, you can pick up the FM signal off of your power line. Apart from this capacitor, this could be going straight to the hot lead. We'll do something different with this. If I have to do it, maybe I'll just do an inductive coupler, basically a gimmick to wrap it around the power line. So we'll see what we end up doing on that. I haven't decided yet. May do some experimentation. Okay, so one of the main things I wanted to get to is that as I was going through here, we've been chasing this noise issue, and I made some progress on this last night. So let me explain to you again kind of some things I've been trying to show. So the noise was only in the FM reception time. Okay, so let me back you up just a little bit, and you know, unless you get lucky the first time out, the first thing you try from troubleshooting isn't always the first thing, but eventually you get there, right? So here's the schematic, all right? Now the things that are dedicated to the FM circuit are the things that we've been thinking about, right? So here is your IF cans that have both the 10.7 megahertz as well as the 455 kilohertz coils in it for both FM and AM, okay? But that's as far as the AM goes, all right? It has this IF tube in between, and they call this a first IF because after the second IF, there is actually a third IF for the FM, okay? So there's a second IF tube that the FM sees. So you're going to get this half of this coil, meaning the top half. You're going to pick up this second IF tube. You're going to get a third IF transformer, and then you're going to get the limiter, and then you're going to get the discriminator coil and the discriminator, well, I should say detector ABC first audio tube here. Okay, so then if I've been thinking about this, is that, all right, so I've been saying that, you know, I didn't think that the detector, the 19T8, is so much of a suspicious tube, because if you see that pin 6 down there, pin 6 is a detector, is a diode, and it's a detector for if you follow it, it becomes, what is that, Victor? And Victor jumps the page, comes over here, and as you can see it goes into the second AM IF transformer. So that serves as the AM detector. And then what comes out of here then comes down to X-ray that comes over here to the switch that then is the AM FM switch to go into the audio circuit here. Okay, so there's your volume control. All right, so let's go back up here to the FM side. So then the suspicious elements were here. And since that pin 6 seemed to be working fine, I've been thinking, well, maybe this is okay, you know, in terms of its voltages and so forth. I've been messing around with this tube, thinking about voltage issues. And of course, I changed a number of resistors in through here as well as capacitors. Okay, and I've been flagging them. But as I got to this one down in here, so this is the second IF tube. There's a resistor here that's for the cathode resistor. It's a 68 ohm resistor. So 68 would be blue, gray, black, right? So here it is. And since I'm holding it in my hand, that tells you that I decided it was wrong, right? So let's see how this resistor does. Place your bets. Now you know it's going to be high, right? How high? As in terms of multiples. So it's supposed to be 68 ohms. There's 250 ohms. So what is that? 4.5 times? 4 times? So that's quite a bit higher. Now I had actually discovered this issue not just by checking the resistance of these capacitors that were in there, but I also pulled out the voltage charts. As you see on some of my other videos, I go through and I just double check what the plates are and so forth. So I had this out and I was going down checking what the voltages were, and when I got to that pin for the cathode on that second IF tube, it was like double the voltage it should have been. It should have been like 0.7 volts DC, and it was like 1.7 volts DC. So basically it was driving that tube into distortion, and I think that's what was been causing the noise and so forth that we were having. So remember before, the theory is that this thing was warming up and therefore it was starting to behave okay. Well, maybe this resistor, you know, maybe it changed, I don't know, but it still wasn't receiving that well. So this has been overnight, and so here's the audio output tube. I got my hand on it, so you know this is dead cold because this gets really hot. Okay, so this is cold from last night, and we're just going to cut it on. So I've got the power coming in here. The way this is now is I've got it actually grounded to the chassis. It's a hot chassis, right? On an isolation transformer. Okay, so we get this triplet out of the way, and we can watch some of these things. Here's your voltage. All right, this got cleaned up. Okay, let's put power to it. 117 volts. Okay, let the tubes warm up. And now this is when FM would really crackle, was when it was cold. I have to change channel, right, for copyright. So I think that we found the source of the noise that was going on. I think that the alignment still needs to be addressed on the FM. But I think we found the problem. It was a resistor that was so high it was distorting the second IF tube, and that's what was causing it. Thank goodness we didn't rip out the IF transformers and started digging around in the capacitors, right? Anyway, sometimes that's one of the things I do is go through and check voltages of plates and cathodes and so forth. I didn't do that first in this case. Had I done that, I probably would have seen a lot of voltages out of whack. But I knew that from testing, I had a lot of resistors that were high. And so it was kind of like, you know, if I got a high voltage or low voltage somewhere, it could have been caused by so many of them. I just kind of started working. Let's go ahead and start working through it. Once I decided this was a radio I wanted to fix up really nice. So anyway, I think we got that fixed. This is all seems to be working pretty well now.
Can't afford to miss. And with up to 3 streams at once, you'll never have to fight about what to watch. Get started today and unlock our library of over 75,000 movies and shows, and save all your favorites with the unlimited DVR, so you can rewatch them anytime.
And it came on cold and it's working good. Last night I had this playing for almost an hour, and I didn't have any problems with it. So happy about that. Okay, so the next thing I'm going to do is go through and finish replacing. You see a few more flags in there that I need to address before I get myself jolted here. I got a few more of these that I want to replace, but these are ones that are also in the AM circuit, so I know they're not really causing anything serious. There may be some just a little bit of distortion in there that this will hopefully clear up a little bit of. This big wire wound resistor that's here, that's part of the power circuit, just because it's starting to look old, and I got some replacement caps, wire wound caps. I think this is a 3 watt. I bought some 5 watts to put in there. It's a 1K resistor. So anyway, I wanted to replace that because it's starting to get the green looking corrosion on the leads, and just go ahead and get rid of that guy. And yeah, I think we're doing pretty good. So I'm gonna get that finished up. I still need to re-put the dial cord on here. I'm going to take this out and kind of clean that up a little bit, and then start putting some things back together. I need to put the fuse block CL90 in here, so I got a lot to do. So I'm going to go cut away and go do that, and I'll be back. Okay, FM's working good.
Roses, talking with Dick. Let's get right down to it.
Got a lot of stations in here. So that's FM. Here's AM.
And a touchdown. Number 10 Clemson at home taking on
AM's working good. All right, so we pretty much finished what we have in here. I've got the, I think it ended up having, I think it was like a dozen resistors that were bad and had to be replaced. There's also, I think it was 17 capacitors all in that were replaced. Let's see, we also cleaned the switch. I've got the power lines now hooked up to the connector right here. I'll talk about that in a second. The hot line, this will become polarized. The hot line will come in where this red jacketed one is. It comes here, runs down, there's a black lead, runs down. First place it goes is a fuse. The current draw on this has been under 300 milliamps, so I've got a 1/2 amp fuse in here, would be fine. As you can see, I've got a CL90 here, which is dropping the voltage down, limiting the inrush when you first kick it on. And then the lead then comes over and goes to the switch. Okay. Then from the switch, it then goes to the rest of the radio, and here's the Y2 capacitor that's here for noise isolation. Okay. I think I got all this done. I think that I'm not going to keep this connection for picking up FM off the power line. I find just hooking up a wire to that lead is all it needs. Okay, so then last thing I got to do on this, I guess, or the next thing I got to do is wire up the dial cord and then put the faceplate back on. I need to do the alignment on the IF transformers back here. In terms of the power connection right here, I took this out and opened it up, and yes indeed this will come out. It's got a U underwriter's knot right here. It's no big deal. I can just replace that and put a new one in there, and I can make sure I have a polarized connection here. And these are polarized. I'll have hot going to the big lead so that the hot, the hot lead could not go to the small one. So anyway, I think that that'll work out good. And then what we'll have is we'll get rid of this old cord, and I've got a new cord here that's brown and it's polarized, and we'll put that on. Put this onto the back, then we'll have a polarized plug cord set up going into the interlock to go into here, and then yeah, so get that done. Dial cord, faceplate, alignment, and then back into the case. See here, that's one going like that. I need this to be the hot lead, just to make sure. Right, okay, that's hot. Okay, this should be the hot lead here. So a small blade. Good. Neutral. Should go to chassis. Very nice. Okay. We now got a polarized plug. Excellent. So after that last segment, I got called in to go eat dinner, and I took the chip out of the camera and plugged it into the computer and let it upload, and I was watching it after I ate before I came back out here and get back to work, and I got to noticing how I had kind of paused for a minute when I was talking about the philosophy of the large pen versus the small pen, and I got to thinking about this, and I got to thinking the chances of this ever happening are just so small. But what if somebody were to come along and say, well, now let's see, if I look at the female part of this, which end would be hot and which end would be neutral? Well, normally hot would be the small pin and the neutral would be the large pin, just like you have on a plug. So you know what? It's not a big deal. I'm going to swap these, and I'll have to swap what I just did here, but that way I'll have that consistency and I'll feel better about it. I don't know why, I'm just weird. So anyway, I want to make that swap and fix this. I'm not going to bother you showing you that again, but I'll show you when I'm done. Okay, that didn't take too long. So yep, I got it switched. So there's a large end, goes to chassis, pull it apart here. Chassis goes to large plug. So we got them switched here and here. And so that's done. I can rest a little easier. All right, on to the rest. Okay, I'm about to restring the dial cord onto here. I didn't really have a chance to show you, or didn't do it, the way the FM tuning works. So it's got two slugs. Inductive tuning is what this has. So there's two slugs that run up and down of a couple of inductors that are here. There's one there and there's one here. So here are the two. They're adjusted by turning these shafts in this nut, and that's for the FM. The AM uses more of a air capacitor type, banana slicer type setup you see in there. So when you turn the dial cord, not only do you turn the banana slicer, but this moves too, and this is held on with a spring, and this can actually be moved independently. You can see the slugs coming up there, and it's got a pin that rides on a little cam down in there. If you look, there's a little disc in there, and I've lubed that up so that will ride on it, and that's what makes that thing tune up and down. Pretty clever. Okay, I'm going to get into tuning the dial cord. I'm going to take this out and clean it first. Okay, so I've got a dial cord on here now. You can see it's working, and that's the hard part, is to lift it up, right, past its weight. And I thought I'd share with you just a little bit about how I do that. I know everybody says, oh, I hate tying dial cords, and yeah, they're not great. But I don't struggle with it too much. So basically what I do is what I use for dial cord is I just use fishing line. Okay. Yeah, you can buy this online for probably something that's appropriate, but this is inexpensive, to get, 100 meters of this, and it's really strong and it doesn't stretch out. It's best to kind of cut it with a knife, but basically what I do is, I'll go in here and maybe I'll find a picture of what the spring looked like before it came loose, or but it's generally pretty safe to assume it kind of comes out about to that length of extension. Okay, so what I'll do is I'll first tie a knot, and I should say a loop, and you want to have a loop that's a non-slipping loop. Newt. All right, so I like to use a perfection knot, so you can look it up online, because if I show you, all you're going to see here is my fingers moving. But I'll tie a little perfection knot here, and basically you bring it around this way, and then this is the part that matters right here. Bring this over the top, and then you tuck that one through the first loop, and you get a loop like this. And if you take your time and you want to make it to where you have as short a loop as possible, that's not hard to do. You just have to plan it ahead of time. I'm just trying to show it to you. So then make it a small one when you make it, and yeah, that's pretty tight. I mean, it doesn't slip. You can take it and it doesn't slip at all. Okay. So then what I do is I go in here and I say, all right, I want the apex of that to be about here, right? And then what I do is I go ahead and then wrap this around and find where that other apex would be. So let's say it's right in here somewhere, okay? So what I'll do is then cut this off like a couple of inches too long, just so you have something to work with your fingers, right? This is not easy to cut. It will not cut with scissors. Works okay with knives. Okay. So you got this, and what I'll do then is take another measurement. And what I'll do, like I say, is I'll put this in here, and I'll take this and I'll wrap it around the shaft like it's supposed to go. If you've got a dial cord that's got lots of pulleys and all that, just go ahead and run it up there through there. And then make it snug, bring it around like this, bring it to where you think that the end of the spring needs to be, okay, on here like this. Okay, then bring this around, and make it to where you say, okay, where do I want this other loop to be in the bottom of the spring, right? Come on. It's hard to do because I'm trying to do this where you can see over my shoulder. So bring it around this way, right? And figure out, okay, it wants to be about there, right? So what I do is I usually take my thumbnail and hold it like that. Okay. And a lot of times what I'll do is I'll just take a Sharpie and make a mark there. But it's actually a little bit easier to see sometimes if you use a piece of tape. So a piece of tape here ready to go. And I'll just tape it to where that tape is in the middle of where that's supposed to be. Also makes it a little easier for you to see what I'm doing, right? Okay, that's where I want it to be. So now what I do is tie another perfection knot. And let me see if I can figure out how to do this. Okay, so what I do is bring it like this. And you want to make it small. Let's see if we can do a smaller version of it this time. So let's see. Make that first loop a lot smaller. Okay. And where the tag is the object loop, right? So bring it around this way. Okay, and it looks like that. If you can see. Okay, I'm going to hold on to it there. Wrap this around. And now you want to pull where you had that piece of yellow tape through. Like that. Like so. Okay. And then pull your knot up. Like that. And that's pretty close. Okay. Pull it kind of tight. It's tight. It's not going anywhere. Okay. Now you can take your tape off. If you can. So it's pretty sticky tape. Okay, now there's a small one, right? So you don't have to make them big like this. I just did that to be quick and to show you how it's done, but you really want it to be small like that. So practice with it. Cut off the excess. You can put a little bit of glue on that if you want to. I just use wood glue. And then what I do is I take the spring and I go ahead and hook the spring on between these two. Okay, because what you're trying to do is you're going to stretch things and try to get them hooked into something. To me, to try to have it hooked on one end of the spring and then wrap it around and then come along with the other and then try to get it into the spring is just too difficult for me to do. I find it easier to hold on to the spring and stretch it to its post. So what I'll do is go ahead and put that spring onto there and then take this, wrap it around where it's supposed to go. Let's see, I think it's this way. Like this. And then bring it around here. I didn't measure this. And then bring it around this way. Actually, I did measure it, didn't I? So that tucks in to here, like so. And then that'll tuck in, oops, like so. And then you'll take the end of the spring. What I like to do is take like hemostats and grab the end of the spring back here behind the end loop, clamp it on there tight, and then just stretch it and hook it on. And you do it that way, you'll end up with it nice and tight, and it works good. Alright, so that's how I do it. I could have made one of those knots a little shorter, but that's okay. It doesn't interfere with anything because the string doesn't go all the way around, see? And the sign of a good knot and good tension is when you're lifting up the plates. That's where the most weight is in your tuner, is make sure it'll do that. And then, you know, you might have a problem with the string stretching, depending on what kind of string you get. I try to get some that doesn't stretch any or doesn't stretch hardly at all. And so you just try it the next day and see if it's still good and tight, but I haven't had too much trouble with it. Anyway, so I got that done. The other thing I've done is I've taken that piece of cardboard that's been on here that's been kind of a hassle in front of the speaker, and I took it off because what I want to do is the speaker's in very good shape, but I've been watching the excursions that this thing has been moving, and it's older. So I think what I'm going to do is put some treatment of some flexible glue on here just to keep the speaker in good shape, because I'm worried about it being played a little zealously by somebody and maybe damaging the speaker. I may change my mind, but because it is kind of nice, I kind of hate to mess it up. But on the other hand, I hate to mess it up, so we'll see. We'll see what I end up doing. But anyway, I think I'm about ready to go to the alignment of this radio. So it'll be an involved alignment because it's a AM FM radio. So we got FM alignment to do, and that's always a little exciting. So I'll get my gear set up for doing that, and we'll get started on the alignment. Okay, so I've got myself set up to do the alignment, and I got to thinking about, well, to finish the alignment and do it properly, you got to have the pointer also set at going to different stations. I could do it in stages, I guess. But if I put the pointer on, I've got to have the dial face on. The dial face covers half the speaker. So if I'm going to take care of the speaker, I got to do it now. And I kind of struggle with it a little bit because the speaker seems to be in such good shape. But I think I'm starting to see little splits here and here. So there's just no time like now to take care of it. Let's see if we can zoom in and maybe you can see what I'm talking about. I could be wrong, but I think I see one starting right here. So I think at least take care of this flexible perimeter, and then we'll just see how I go from there. I've already cleaned it with a soft brush to get all the dust off of it, and but I think there's no time like the present to take care of it because now I've got the dial face off, got everything out of the way, so I better take care of it now. Okay, we all knew this was going to happen. Once I got started on this, I'd just end up doing the whole cone. I'm using the Aleene's tacky glue, original, cut with water. This was, first time I saw this pointed out was by Don over there at Restore Old Radios. Great channel, by the way. And video I saw he was using this and it seemed to do pretty well, so I've used it on a couple other projects since then. I think one of them that ended up in a video was the Zenith long distance that I did before this one, and I thought it turned out really well. It had splits all through it, and this stabilized it all and got it all nice and quiet. And it kind of looks like heck right now, but once it dries clear and a little glossy, and it'll be nice. I may go over this a couple of times. I don't want to get it too wet, obviously, but the water is just barely enough there to make the glue easier to spread. It's not really super runny. Okay, well, I'm going to finish doing this. I may do a couple more coats, and we'll come back and hopefully it works fine. I'm sure it will.
Today's 60 seconds.
Okay, so we got the speaker recoated. You see it dried looking really nice. It's been a couple of days. I had some things I got to go do, so it's really nicely dried, and I think it looks good. And yeah, I can definitely see there was something happening here and maybe here and maybe here. So I'm glad I went ahead and did that. So, and it seems to
InstaView counter depth max French door refrigerator.
sound just fine.
Lifestyle expert Yvette Rios.
Okay, so it's time to maybe look at doing the alignment, right? So let me back you up some. Always the wrong way. I'm sorry. So the way I've got this set up right now is I'm currently on a strong station. This is a relatively close station to where I am. But just to kind of get an idea of how the reception is.
This meant that the state of Franklin's capital was now on Native American property.
So I'm getting other stations. It's not bad at all. Something in there. So, and also I wanted to point out, just as I'm doing the alignment on this, is the noise level that's in my shop here. I'll give you an example. If I go back to the station that we were listening to a second ago, if I can find it.
And travel to visit our grandchildren.
You can kind of hear the background noise there. I have a light over here that I use a lot, and if I cut this on, you can hear it create some noise. So that pretty much happens, I think, all over the band with all the different things we got going on in the house. And that's why I like to take these things out to a park somewhere to hear how they receive without all the modern appliances. But anyway, I'm ready to start doing the alignment on this. I'm going to do the AM alignment. I'm going to use a VTVM attached to the output of the audio output transformer, which is the input to the voice coil. This has been on for over an hour to get it to warm up and stabilize. And I got some leads hooked up to it, so I'm going to go ahead and hook these on to the speaker here, right here, and you see that get a needle response.
Size anytime. Like $1 Coke.
Okay, the needle is responding. Okay, so the alignment instructions are to fully close the gang, and I'm going to turn on the IF frequency, which is 455 kilohertz, right? So let's turn this on. I tried to do a little bit of homework before we got started. Okay, I'm right at 455 is what we want, right? Not 445. So much for homework. $455. Okay, can you see that? Okay, it's 455 kilohertz. All right, so I'm going to go ahead and turn on the modulation. And you can hear it. I'm going to be moving this level down as I bring up the balance on the volume control. Bring up the volume, and I'm going to lower the signal. So I've got a lot of background noise, but you can hear the tone. But I want to be able to see motion on here, so I am going to lower the volume some so I can get the tone just a little bit more above the noise floor. Now you can see it moving there. Okay. Let's try it there. Let's see what we get. Okay, so I'm going to turn the level, turn it down. Okay, so the transformers that are used in AM are here and here. These have both AM and FM coils in them. And what they are is there's four sets of coils that are looking up at you from the bottom. And some of them are short and some of them are tall. So some of them go down quite a long ways and so forth. The order in which I'm going to be doing the alignment is basically start at the detector and work your way back towards the antenna. So it's going to be 1, 2, 3, 4. So I'm going to do it both by ear but also looking at the meter to get some kind of clue for did it really go up or not. So I'll zoom in just a little bit. And let's see what we get. Okay, I'm going to turn the level up some. Okay, it's dropping off. Stronger. Dropping off. Let's say about there. I'm going to lower the level a little bit. Wow. Wow, that's quite a change. Let me lower the level again. getting really sensitive. The noise floor is getting too loud. I'm going to lower the volume and raise the level again so you can hear it above the noise floor. Yeah, I think I've hit the peak there. I'm going to say it's in there somewhere. With that much movement, it's going to affect the other ones, I'm pretty sure. We adjust the levels. I might, well, it's hard to tell. We'll go back to the first one again and start over. I can probably mess with this some more a little bit later, but let's just see how that receives now. Make sure it still works.
That face mask. He sure did. Yeah. They cannot review that. But he definitely got the face.
Broadcast. Close your back and set up a meeting. That's 660.
Green, brown, black, brindle, simply marvelous. You know, it's such a treat to watch a drug like this. Now, let's see him in action. Look how he makes it.
Girl who was left abandoned on the Galveston is held without bond. Police say the 17-month-old Hannah Donko was found suicide.
TDA suspected in crimes in 15 states: Arizona, Texas, Chicago.
I think that sounds really good. I don't hear any distortion. A distortion in the reception that might be driven by an alignment issue. That sounds good.
And then there's 3 lawsuits.
You don't care one way or the other usually about bonfires?
Now before I can do much more with the alignment, I need to put the faceplate back on and put the needle on, because I gotta set the dial at a certain point when I set the oscillator. So I'm gonna do that now and I'll be back. But I'm happy with the way this sounds. I may be able to mess with it some more later. I'll mainly do it by ear, I think. Okay, oscillator's at 1600. Yeah, that's off a lot. I want it to be around there. Okay, 1600. Now we'll go to somewhere around 1400, set the antenna. Turn the signal down to emulate a weak station. Now what I want to do is tune the antenna for that. Okay. See if we can find anything weak around here. There's a weak station. Let's see if I can tune that in just a little better, even though that's really a DX. Okay, I think that's it. All right, let's just go hunting here. Most of my strong stations are down here.
And we will go to an update with Marco Bullet.
Infinity Sports Network. Sports Flash.
That's KILT.
Possibly on the line with Matthew Stafford helping the Rams find their
So when I always talk about being hard to pick up in the house.
Balance it out 2 by 2. Stafford has the snap. 4-man rush. Pressure in his face. Goes out the left side. Bucks the rush. Flip to the end zone. Cut!
Okay, that's good. I'm going to now get this set up for doing the FM alignment. So I'm going to get rid of the VTVM. I didn't need it anyway. And bring down the SG165, and then we'll look at doing the FM alignment on this. I guess I need to bring the oscilloscope down too. So anyway, it'll take a while to get me that and get all that set up. So I'll bring you back when I get all that done, get it ready to show. Okay guys, as you can see, we're set up here for doing the FM alignment, but I think this video's kind of gotten long enough. I'm going to break it off here, and this will be the end of part 2. In part 3, we're going to get into doing the FM alignment on this using the equipment you see there, and we will get working on that. So until then, hey guys, I appreciate you guys watching, and really appreciate all the kind comments and people chipping in about their version of this model, and I'll see you when we get to part 3. Until then, thanks. Happy New Year. Talk to you later. Bye.